Okay, it looks like you can see the slide. So I'm going to go. So I'm going to talk about using a constraint-based system to blend 2D tile-based games. And the system itself is called Sturgeon, which is actually going to be presented later on at AID in a couple days. But I'll just, if you're interested in more of the details of kind of like the underlying base system, you can come to this talk and find out more. But just as a brief overview, it's the system that has this kind of like mid-level API for setting up constraint satisfaction problems. Very small kind of like API, I think, that you can make variables, constrain the counts of things, constrain kind of like implications, and then run the solver and get the results. And this sort of mid-level kind of API maps to various low-level solvers like SAT solvers, SMT, answer set solvers, so you can try, different things and find out which solvers work well. And then based on that, it has worked out how to have some design rules for 2D tile-based games, like tile placement, learning like local tile patterns and tile distributions from examples, and even things like constraining the level goal to be reachable from the start of the level. And then we showed working on several games, some of which I used in this work on game blending, and show how it can be used to sort of complete and repair levels, and even explore the expressive range of the generator, for example. So there's more on that later this week. So this work is basically building on top of all of that and looking at actually blending different games together, right? And why might that be interesting? Well, maybe blending sort of different aspects of different games might be ways of coming up with new games. For example, possibly something like Spelunky is a combination of like platform games like Mario and roguelikes. Metroid is maybe kind of a blend or a combination of something like Mario and Zelda, where you collect items and power up and that kind of thing. Super Smash Brothers, of course, is a combination of like lots of different games and characters and items and that kind of thing. And then there are other, there are games like ROM Check Fail, I think, which, also just takes like a bunch of characters and levels and things from different games and just kind of like puts them all together in weird combinations to see what comes out of it. And so this can be thought of as kind of a form of combinational creativity, which Bowden discusses as unfamiliar combinations of familiar ideas. So this is kind of this idea of maybe combining things that are different and getting something new and interesting and maybe creative out of it. There's been some work recently in blending games, some work looking at, for example, using variational autoencoders to generate blends of different games, even extracting sort of like the physics out of a blended game level and seeing how the character might move, and even some work looking at blending like very different genres of games like dungeons and platformers and that kind of thing. So this is sort of contributing to that. And this is also building on top of a lot of work that's been done in procedural content generation via machine learning, because some of the constraints are basically learned from example levels of existing games and then apply those to generate new games. For example, the increasing popularity of things like wave function collapse that are kind of constraint-based level generation systems that learn from examples. So constraints, might be a good way of blending different games together, because in some ways they can be fairly modular. If you have different types of constraints from different games, it's relatively straightforward. It seems to kind of, turn some of them off and some of them on and just combine them in different ways. And that's kind of what we did in this work, is, just combine constraints from different games and to generate some kind of new thing, rather than using sort of like all the same constraints that were set up for the same game, right? Just sort of pick and choose different ones from different games and get something new. And so the three types of blending that I was going to talk about today are, and I'll go through more of these in a little bit more detail, is blending the functional structure of one game with the images from another game. So you get something kind of that looks like one game, but also another. Blending the tile patterns from one game with the reachability rules, basically how the player can move through the level to reach the goal from the start from a different game. So blending sort of like the tile patterns from one game and how the player moves from the start to the goal from another game to get something new. And then also blending different games within a single level. So you have a level that's like piecewise assembled from different games, but still sort of within each region respects the individual game's constraints. And to do this, just a little bit of, there were a little bit of modifications required for the base Sturgeon setup that will be described later, but we added support for extracting information from multiple example levels and different games and sort of all the bookkeeping necessary to do that and keep track of which things came from which games and so on. We used, for the low level solver, we used PySat's RC2 solver, which in previous work we had found is fairly flexible and fairly efficient for solving the kinds of constraints problems that we set up. And for most of these examples, we used fairly simple like neighbor tile patterns, where essentially, a tile will just individually constrain a few of its neighbors to be something that it saw in the example. Even though the system has support for much larger kinds of patterns, we found using simpler patterns sort of gave it more flexibility, and also usually in the examples we used soft pattern constraints where it was okay if they were violated in some places, and it would still sort of count as being solved, but it would try to minimize those. And also the system will we generated basically everything in one pass. It's possible to generate like the levels in multiple passes, but in this work we just used one pass to generate the whole the functional part of the level, which basically sort of means, well, we'll see in a second, like what the function of the tiles is, whether they're solid or whether they're open, generally speaking, although there are some other ones, and then the image part of the level, like what they look like. Those can be done separately, but in this work we just did it all at once. And another extension that we added was a support for a in this work we're calling a game grid, which is essentially another 2D grid that specifies, and you can specify it like a per location basis on the grid which game is supposed to be used. So a game grid like this would basically say this part of the level is supposed to be Mario, this part of the level is supposed to be Kid Icarus, and this part of the level is supposed to be like a cave, essentially. In this work, we used 6 games. So one of them was this sort of cave, which is just like a custom kind of cave exploration game where you walk through the cave. One of the dungeons from The Legend of Zelda, Tomb of the Mask, which is a game where you kind of slide until you hit a wall and then you stop and you have to get from the start to the goal. Super Mario Brothers, which is a fairly standard platformer game, and Kid Icarus, which is also probably fairly familiar, although it does have like column wrapping, so you can go off one side and come off the other. And another game called Super Cattails, which used one section of that game, which is a platformer, but it's kind of interesting in that there's no like regular jump. You can't just like jump from anywhere, but you can do stuff like climb up walls and jump off the walls and jump off edges and things like that. So it has like slightly different movement rules, but it's still a platform game. So first I'll talk about blending the functional structure and the image. So in this case, we use the functional structure from one game's level with the image tiles and patterns from another game. And this is done essentially via what in the system has support for a tag grid that kind of specifies what tiles can be placed where. And roughly speaking, you'll see this as sort of like solid tiles and not solid tiles, but there are kind of other details. And where the games share a tag, then it's possible to do this. And down here in the corner, there will be some timing information on how long it took to actually generate these. So we can see here at the top, this is a tag grid that represents like Super Mario level, right? And then from that, we can kind of basically derive this game grid that says use Kid Icarus tiles basically everywhere that you can, but in the places where there's pipes and stuff like that, there's no real equivalent in Kid Icarus, so use Mario there. And then you end up with something like this, where it's the structure of Super Mario Brothers level, but it is sort of like looks like visually the style of a Kid Icarus level. You get like the trees growing out of things and the columns and so on. And you can do the reverse, right? Basically, here's a Kid Icarus level, and we ask it to use Mario tiles everywhere it can, and you get things like this. Interestingly enough, this is just the top of the level because the level is very tall. The way that the system sort of accounts for the spatial distribution of tiles, right? You kind of get these Mario clouds part way up the level only, and they're not at the bottom, at the very top, and that kind of thing. And one of the other interesting things is like it places here's the goal, right? And it tries to put like a little bit of the Mario flagpole here right next to the door where the Kid Icarus exit door is, which is kind of interesting. Another type of blending that we looked at was blending patterns. So the tile patterns that are learned from one game with the reachability rules, essentially like how the character can move from another game. And so just a few examples of that. This is the cave game, which is sort of generally a 2D top-down kind of like exploration game with platform rules. So the character kind of, this one was a little bit clearer, right? But you go over and you fall, and then you come back over here, and then you can jump and fall and jump around, and basically have to jump up to the exit there. And I guess I'll probably talk about this more in the general Sturgeon talk, but the constraints are only looking for a path to the goal. They don't care how long or short it is. So the paths that it gives sometimes are very convoluted like this, but they do have, they do go from the start to the goal. This is similarly like Zelda patterns, but with a platform game movement rules. So you have to jump up and go through the door and that kind of thing. This is Zelda with Tomb of the Mask movement rules. So the player has to kind of like slide around until they hit a wall and then they stop. And one of the interesting things was here, I mean, sometimes some unusual things occur when the rules for different games are blended together. In this case, like the Triforce would be is not sort of completed with the tiles because the player has to have a wall to stop at, and it also has to stop at the Triforce. So the solver basically had to like break the Triforce by putting a block essentially somewhere in it so that the player could stop on top of the Triforce. There might be ways to address that. This is Super Mario Brothers with Super Cattails movement rules. So the player can't just like jump anywhere, but they have to like jump off of a ledge or climb up a wall and jump. You can also get Super Mario Brothers with Tomb of the Mask movement rules. In the interest of time, I might go through some of these a little bit quicker. This is Kid Icarus with Super Cattails, Kid Icarus with Tomb of the Mask rules. And then the third sort of blending I was looking at was just blending 2 or more games within a single level. And that can be done with the game grid. So here we have a level that starts off as the cave game, and then as soon as you get into the middle section, it's Tomb of the Mask, and the character slides basically until they hit something, and then it turns back into the cave. And you can, this is Super Cattails with Kid Icarus, and they kind of have a section of each cut out from the middle of them. So, the character can't do a regular jump until they get into the Kid Icarus area and that kind of thing. This is using the tag grid here. So this is the tag grid and this is the game grid to basically cut out kind of like this horizontal, vertical, horizontal piece of the level. And then the game grid says, the horizontal part is Mario, and then Icarus, and then Mario again. And you can combine, this is 3 games. So we have Mario as a platformer, then the character kind of has, starts moving around like the top-down cave game, and then they get the platformer for Kid Icarus again. And like, interestingly, things like once you get into the Kid Icarus part of the level, you can actually stand on the cave part and jump and that kind of thing. And you could, it supports all kinds of combinations, although they start to get very difficult to sort of figure out what's going on. And if you were playing it, very hard to tell where the goal is. So this is like a checkerboard. This is another combination where first we generate a cave level, and then the solid parts become Icarus and the open parts become Mario. So in the future, I'm interested in actually trying to be able to play the generated levels that have blended reachability, like this one. Like, what is it actually, when you play it, like what is it like to switch from like a platform rules to sort of top-down navigation rules in the middle of a level? But let the system determine which games to use in some parts. So right now the game grid has to fully specify which game is used in each location, but it would be interesting to give some flexibility there. The game grid doesn't necessarily just have to be completely different games, but it could be sort of like different styles or areas, or even maybe difficulties, if that can be captured within the same game. And it might also be interesting to have multiple simultaneous reachabilities, so a level can be played by totally different games. And also, I was working with the tile grid a lot in the game grid. I recently saw at the grocery store these potato grids, and it might be interesting to try to incorporate those in some way. So thanks. That's